The resistor is a passive electrical component that creates resistance in the flow of electric current. In almost all electrical networks and electronic circuits they can be found. The resistance is measured in ohms, omega. An ohm is the resistance that occurs when a current of 1 ampere, A, passes through a resistor with a 1 volt, V, drop across its terminals. The current is proportional to the voltage across the terminal ends. This ratio is represented by Ohm's law, V equals I/R. Inductance is the tendency of an electrical conductor to oppose a change in the electric current flowing through it. The flow of electric current creates a magnetic field around the conductor. The field strength depends on the magnitude of the current, and follows any changes in current. Wikipedia. SI unit, Henry, H. Dimension, M1 middle dot L2 middle dot T minus 2 middle dot I minus 2. Derivations from other quantities, L equals V, I, T, L equals phi, I. Capacitance, property of an electric conductor, or set of conductors, that is measured by the amount of separated electric charge that can be stored on it per unit change in electrical potential. The unit of electric charge is the coulomb and the unit of potential difference is the volt, so that the unit of capacitance, named the farad, symbolized F is 1 coulomb per volt. 1 farad is an extremely large capacitance. Convenient subdivisions in common use are 1/millionth of a farad, called a microfarad, μF, and 1/millionth of a microfarad, called a picofarad, PF. Older term, microfarad, μF. If electric charge is transferred between two initially uncharged conductors, both become equally charged, one positively, the other negatively, and a potential difference is established between them. The capacitance C is the ratio of the amount of charge Q on either conductor to the potential difference V between the conductors, or simply C equals QV. Voltage, also called electromotive force, is a quantitative expression of the potential difference in charge between 2 points in an electrical field. The greater the voltage, the greater the flow of electrical current. That is, the quantity of charge carriers that pass a fixed point per unit of time, through a conducting or semiconducting medium for a given resistance to the flow. Voltage is symbolized by an uppercase italic letter V or E. The standard unit is the volt, symbolized by a non-italic uppercase letter V. 1 volt will drive 1 coulomb, 6.24 by 1018, charge carriers, such as electrons, through a resistance of 1 ohm in 1 second. Voltage can be direct or alternating. A direct voltage maintains the same polarity at all times. In an alternating voltage, the polarity reverses direction periodically. The number of complete cycles per second is the frequency, which is measured in hertz, 1 cycle per second, kilohertz, megahertz, gigahertz, or terahertz. An example of direct voltage is the potential difference between the terminals of an electrochemical cell. Alternating voltage exists between the terminals of a common utility outlet. Alternating current, AC, power is the standard electricity that comes out of power outlets and is defined as a flow of charge that exhibits a periodic change in direction. AC's current flow changes between positive and negative because of electrons. Electrical currents come from the flow of these electrons, which can move in either a positive, upward, or negative, downward, direction. This is known as the sinusoidal AC wave, and this wave is caused when alternators at power plants create AC power. Direct current, DC, power, as you may suss from the name, is a linear electrical current. It moves in a straight line. Direct current can come from multiple sources, including batteries, solar cells, fuel cells, and some modified alternators. DC power can also be made from AC power by using a rectifier that converts AC to DC. DC power is far more consistent in terms of voltage delivery, meaning that most electronics rely on it and use DC power sources such as batteries. Electronic devices can also convert AC power from outlets to DC power by using a rectifier, often built into a device's power supply. A transformer will also be used to raise or lower the voltage to a level appropriate for the device in question.